Hi everyone, my name is Rami and I'm a master's student with Dr. Shado. So this is lab 4A, which is microdevelop for coarse aggregate. So the purpose of this test is to measure the abrasion resistance of coarse aggregate in the presence of water and an abrasive charge. In this case it's going to be steel balls. So we're going to take 1500 grams of coarse aggregate and water and steel balls, and we're going to put them in a container and have them rotate for 2 hours, and then we're going to measure how much came off of the aggregate due to the collision with the steel balls. And the water is there because coarse aggregate is more susceptible to abrasion when it is wet. So we have the 1500 grams of coarse aggregate already soaked in water for 24 hours, and now we're going to go and put it in the jar and start the test. Alright, so here we have the 1500 grams of coarse aggregates soaked in 2 liters of water, and then here we have the 5 kilograms of steel balls. So we're going to put everything in this jar. And then we're gonna secure the jar and start the test. So we have to secure the jar to make sure nothing leaks. And then we're going to move the jar and place it in the microdevelop apparatus. So we're going to start the test, let it run for 2 hours, and come back and measure how much came off of the aggregate by doing some sieve analysis. So now the 2 hours are over, so now we're going to start sieving the material. So we're going to take out the jar. So now here we have 2 sieves. The 4.75 millimeter sieve at the top, and at the bottom there's the 1.18 millimeter sieve. So any material that passes through the bottom sieve, the 1.18 millimeter sieve, that's how much came off the aggregate due to abrasion. And then we're going to take the masses on the 2 sieves, and we're going to compare the total mass to the original 1500 grams to calculate the percent loss due to abrasion. So now we're going to dump the material so we can start sieving. Okay, so first we need to wash the aggregate so that any particles that got stuck on any of the aggregates gets washed down through the sieves. And now before we actually start sieving, we need to take out the steel balls. So this is a magnet. It turns on and off. So we're gonna take steel balls out of the sieves before we start shaking the sieve. So now we removed all the steel balls from the sieves, so now we can actually start sieving. So now all the material that is finer than 1.18 millimeter got sieved down, and we have the two masses that's on the two sieves right now, and that's the mass that we're gonna put in the oven to oven dry, and compare that mass to the original 1500 grams to calculate the percent loss. So the reason why we had two sieves, even though we're only care about the 1.18 millimeter sieves, because we don't want to damage the sieve if we place all the heavy aggregate on it. So we place it on the 4.75 millimeter sieve. And now we're going to take our aggregate and we're going to place it in the oven. We're going to come back after 24 hours and take the mass of that. So now we're going to take the oven dried mass of our aggregate. So now we can compare this mass to the initial 1500 grams, which was also oven dried, to calculate the percent loss due to abrasion.